So we're going to do a little unit recap of what you need to know for this unit test on Wednesday. Okay? And basically, the unit test is on 2 outcomes from the course. The first one is on angles, and that's basically what your quiz covered. Okay? So, just make sure I'm on my pen. Everything that I'm writing down here, you guys should be writing down on your piece of paper in front of you, because you can use this as like your quick study reference guide. Okay? Okay. What you need to know. Okay, so the first thing we talked about were angles. Okay, and we talked about what is an angle. Okay, what is an angle? It's the measure of the space between 2 intersecting lines. And then we also talked about the classification of angles. How do we classify them based on size? Okay, and so the different classifications we came up with were, well, what's the smallest angle that we classify? What's that called? Do you remember? Acute, yes. So there's acute, which is 0 to 90 degrees. Okay. So you can kind of picture it, it's like this. What was the next one after acute? If you don't remember, you could actually flip over. Yes. The next one is a right angle. A right angle. And what is a right angle? Yeah, 90 degrees, yes. Okay, there we go. Okay, and after a right angle, what's the next biggest size? Yeah. Not straight. There's one in between right and straight. Yep. Obtuse, yes. Obtuse. Okay, and that was between 90 degrees and 180 degrees. Okay, so that maybe looks like this. Okay. And then what was the next one that you just mentioned? Straight. Yep. And a straight angle looks the way it sounds. It's a straight line, and it's 180 degrees. Okay, so it's like this. Okay, and then after a straight angle, what's the next one? Yep, a reflex angle, correct. Okay, so this angle is, what does it have to be between? Yep, 180 to 360 degrees, correct. Okay, and so it kind of looks like this. It's like the other side of an acute angle, right? And you can tell which angle to look at based on where that circle is. Okay, so we looked at these classifications of angles. We also looked at what it means for 2 angles or more to be either complementary or supplementary. And we just discussed that. Okay, so we talked about complementary and supplementary. Okay. So if we know 2 angles are complementary, what do we know about them? Yeah. They add to 90 degrees, exactly. Okay. What would be an example of 2 angles that add to 90 degrees? Like, for example, let's say one of the angles was 10 degrees. What would the other angle be? 80, yeah. So, for example, 10 degrees and 80 degrees, we would say that these two are complements of each other. Okay? Supplementary. What condition do supplementary angles have to meet? Yep. They add to 180, correct. Okay, so an example, let's say again, one of the angles was 10 degrees. What would the other one be? 170, yeah. There we go. Now, does every angle have a complement? Okay, so what would be an example be of an angle that does not have a complement? Yeah. Say that? 92 degrees does not have a complement, exactly, because it's too big, right? So any angle greater than 90 degrees doesn't have a complement, and any angle greater than 180 degrees doesn't have a supplement. That's right. Okay? We also talked about bisecting an angle. Okay? So what does it mean to bisect an angle? If we're bisecting an angle, what are we doing to it? Yep. Having it, yeah. So bisecting an angle means we have it. We cut it in half. Okay? We talked about what it means for two lines to be perpendicular. So a lot of what this first little bit was about was definitions, right? Two lines are perpendicular. What do we know about them? What do we know about perpendicular lines? Yeah? If I said that line A is perpendicular to line B, yeah. Like this can be line A and then line B would be like that. Okay, yeah, so they would look like this. Okay. What condition do they have to meet? Yeah. They intersect or they meet at 90-degree angles. Yeah, so they intersect at 90-degree angles. Okay, and then the symbol that we use looks like this, and we could put this little box in the corner, and that box indicates that we have a 90-degree angle. Okay, so this is kind of the angle piece. Oh, there's one other thing that we talked about, which was how to use a protractor to measure an angle. So I will actually just maybe bring an angle down, and I know that you guys won't really be able to put this into your recap, but you could put this as a note in your recap that it's something that you should practice. And I believe you all should have a protractor that I've given you, and if you don't, let me know and I'll give one to you. There we go, I'll bring that one down. But I'm going to now draw an angle. There we go. Okay. And I'm just going to bring this protractor down so that we can just see how to do this. And I am recording this right now, so if you guys want to go onto D2L later, I'll post a link to this video, and then you could take a look at it if you want to review. Okay, so another thing that you guys will need to know how to do is to measure angles with the protractor. Okay, so the idea with this is we want to take this guy and the vertex of the angle, which is kind of the pointy part, the corner. Those of you that are on your phones right now, you need to get off of them. Thank you. Okay, so you want to take this pointy part right here, the vertex, and you want to take the sort of perpendicular part of your protractor and put it right there. Okay, and then this horizontal line at the bottom of your protractor needs to line up with one of the two arms of your angle. So what I'm going to do with this protractor is I'm going to rotate it. No, I don't want to do that. There we go. Come on. There we go. I'm going to rotate it like that so that it's sitting right on the arm of the angle. Okay? And then do I need to see, can you guys see that there's two numbers along here? There's like a 0 and a 180. Which numbers should I follow? Yeah. The 0, yeah. So wherever the 0 is, you're going to follow the numbers that are along there. So if the 0 is on the inside, follow those numbers. If the 0 is on the outside, you follow those numbers. Okay? So I'm going to follow those numbers around, and here's my other arm, and I'm just going to look there, and that's like 60, that's 65, so that's about 66 degrees. Okay? So I would say that this angle is 66 degrees. Okay? Now on your quizzes, if you were off by about 1 degree, that's okay. That's like human error. Some of you were consistently off by about 4 or 5 degrees, so I would have deducted some marks for that. Not a mark every single time, but you've got to have some degree of accuracy here. You can't just keep rounding to the nearest 5 degrees or nearest 10 degrees, okay? You've got to be a little bit more accurate than that. If you thought it was 67 degrees instead of 66 degrees, that's okay, okay? But you can't just round to 70 or round to 65 all the time. Okay, so take the time to be a little bit more accurate. Okay, so this is another thing that you will be expected to know, which is how to measure an angle with a protractor. Okay, and that is one outcome of the test. So you are going to get 1 mark for that part of the test. Those of you that I just asked to put your cell phones away, I'm going to ask again. Thank you. Okay. The second outcome of the test is on parallel lines and transversals and the angles that form within them. Okay, so this is our second outcome. And your quiz was not on this one. So if we know that 2 lines are parallel to one another, okay, so I've drawn a set of 2 lines. How would you know from looking at my diagram that these 2 lines are parallel? Yeah. Yes, I'm using, and what specific symbol can you tell? How can you tell specifically from this diagram that these are parallel? Yeah, the arrows, yeah. So if you've got these 2 arrows, that indicates that the lines are parallel. Can we rely on our eyesight to tell that 2 lines are parallel? Correct. You can't say that they are parallel because our eyesight is not good enough for that, but you can rule out if 2 lines are parallel, right? So if you see one line's here and another line's there, I can say, yeah, those 2 lines are going to meet, so they are not parallel. And on that note, actually, what are parallel lines? How do we define them? There you go. Thank you. Lines that never meet or never intersect. Okay? Now, what we can do with parallel lines is we can take another line and we can run it through a set of parallel lines like this. Do you guys remember what that line is called? It starts with a T. Yeah, it's called a transversal. Yes, so this is called a transversal. Okay, and when we intersect a set of parallel lines with a transversal, a bunch of angles are formed. How many angles are formed? 4, well, 4 are formed over here, and then another 4 are formed over there. So there's actually 8 in total. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8 different angles. Are these angles all different? Or are some of them the same? Yeah, some of them are the same, and yes, that's true. How many different angles do we actually have? How many different angles are there? Yeah, we only have 2 different angles, that's right. Yes, so the angles that are the same okay, well, let's start with angle 1. Which angles are the same or equal to angle 1? Angle 1, angle 5, yes. What else? 8, and what else? There's one other. 1, 5, 8, and, yep, 4, yes. Okay, so those 2 are equal, or those 4 are equal. And what's the other set of 4 that are equal? What's the other set of 4? 2. 3, 6, and 7, yeah. And when I'm looking at it, I kind of look at the ones, which ones are acute and which ones are obtuse. That's how I do that sort of analyzing, because it's easy for me to see. I can picture a 90-degree angle quite easily in my head because I see them all the time, even in this room, right? So if I can just say which are the acute ones and which are the obtuse ones, that's an easy way for me to tell. Okay, now the ones that aren't equal, like 1 and 2, for example, do they have a relationship with one another? What do we know about angles 1 and 2? They're not equal, but we do know something about them. They add to 180, yes. So the ones that are not equal add to 180. And in fact, we know that 1 and 2 add to 180 because together they make a straight line. These 2 angles are called angles on a line. Okay, and so what that means is that if we know 1 angle out of 8 that's intersected by a transversal, where parallel lines are intersected by a transversal, we can figure out all 8 of them. Okay, now in fact, these angles, pairs of these angles, have special names. Okay, and so those are also things that you guys are going to need to know. It's not only that these are just equal, but they have special names. The pairs have special names, and also you need to know their relationship between the pairs. So are they equal to each other, or is it that case where they add up to 180, which means they're supplementary to each other? Okay, so the types of angles that we can get are corresponding, okay, and corresponding angles are basically in the same position where the transversal hits each line. So when I actually look at this intersection up here, okay, I can kind of, do you see how this kind of divides it into 4 sections? And I can kind of look, okay, top right, bottom left, top left. Does that make sense? Yes? Or no? Thumbs up, thumbs down. Do you want me to do that one more time? Did everyone catch that? No, we're good? Okay. Here, same thing, right? Top right, bottom left, top left. Yeah? Okay. So the ones that are both in the top right, for example, 1 and 5, those are called corresponding. The ones that are both in the bottom right, 3 and 7, those are called corresponding, etc. Okay? So, for example, 1 and 5. Those are called corresponding. Okay? Now, are corresponding angles equal, or do they add to 180? What's the relationship? Are they equal, or do they add to 180? Yep. They're equal. Okay? Now, if you're not sure, take a look at angle 1. Is that acute or obtuse? Those of you that are looking down, you need to look up so that you can see. I can see all of your eyes right now because I'm looking at the class. Okay? Is that one acute or obtuse? You guys can all say it at the same time. I'm asking everyone. Acute. What about that one? Is that acute or obtuse? Acute. So if they're both acute, they're equal. There you go. Okay? So that's one thing we need to know. The other one are alternate interior. Okay? Now remember we talked about the rest of the angles can either be interior or exterior? Do you guys remember that? Yeah? So if they're interior, they're inside the lines. So the angles that are inside the lines are 3, 4, 5, and 6. Okay? If they're alternate interior, what does that mean? Yeah.
It's like 4 and 5, they're interior, but they're on different sides of the transversal.
They're on different sides of the transversal. Exactly. They alternate sides of the transversal. Yeah. So like 4 and 5 or 3 and 6. Okay, so example, 4 and 5 or 3 and 6. Okay? Are those equal or do they add to 180? 4 and 5. Are those equal? Or do they add to 180? Look at 4 and 5 and ask yourself, are those both acute? Or look at 3 and 6 and ask, are those both obtuse? Yeah? So what does that mean? Are they equal or do they add to 180? They're equal. Yeah. So these are both equal. These are both equal. Okay? The other one that we can have is alternate exterior. Okay? Now, exterior means they're on the outside. So 1, 2, 7, and 8 are on the outside. Alternate, again, means that they are on different sides of the transversal. So here's angle 1. I have to cross over the transversal and go to angle 8. Okay? Here's angle 2. I've got to cross over the transversal and go to angle 7. Okay? So for example, 1 and 8 or 2 and 7. Okay? Equal or add to 180? What do you think? 2 and 7, yeah. 2 and 7, equal or add to 180? They're equal. They're both obtuse, right? Or you could look at 1 and 8 and say, okay, those are both acute. Those ones are also equal. Okay? So those are alternate interior and alternate exterior. And then the other ones that we can have are the interior angles that are on the same side of the transversal. Okay? So interior angles on same side of the transversal. This one's a bit of a mouthful. Okay, but luckily, it kind of sounds the way that it looks, right? So we're looking at interior angles, ones that are on the inside, and they're on the same side of the transversal. What would be an example of a pair that fits that description? Inside angles that are on the same side of the transversal. 4 and 6, because they're on the inside and they're the same side of the transversal. Okay, so for example, 4 and 6, or 3 and 5. Okay, now are those ones equal? Are 4 and 6 equal? No. Okay, so what do we know about those two then, if they're not equal? What do we know about them? Yes, they add to 180. Okay, we got a couple more, and then we're done. Okay? Okay, so we can have interior angles on the same side of the transversal, and then we can have exterior angles on the same side of the transversal. Okay, so now we're looking at stuff that's on the exterior, outside, but still on the same side of the transversal. Okay, so remember the ones on the outside are 1, 2, 7, and 8. So for example, angle 1. What's on the outside but on the same side of the transversal? Look at the ones on the same side of the transversal to angle 1. Which one is on the outside? 7, yeah, 1 and 7. Okay, what about the one for angle 2? 8. Does that make sense? Yeah? Okay. So 1 and 7 and 2 and 8. Okay. And are those ones equal to each other? Let's look again. So 1 and 7, do those ones look equal? No, they don't, okay? This one is acute, that one's obtuse. So if you can really get this idea when you're comparing of acute versus obtuse, that can really help determine if they're equal or not. If they're not equal, then they add to 180. Okay? Now, these are sort of the relationships between angles in parallel lines, but then there are two other types of angles that show up in parallel lines that also just show up whenever you have intersecting lines in general that are really helpful to know. And one of them I've already mentioned, and those are called angles on a line. Okay. And angles on a line, well, we could see it in the picture here, so I don't have to scroll up. That would be an example like 7 and 8, because they lie on a line together, right? So if they kind of make up a line. Okay. Okay. What do we know about angle in 7 and 8 if they lie on a line? They add to 180, yeah. Okay. And then the last one, the last pair, are called vertically opposite angles. Okay, and vertically opposite are basically when two lines intersect. So we don't even have to look at the whole set of parallel lines here. We can just look at this bottom part. Vertically opposite means they're across from each other. So for example, 5 and 8 are vertically opposite. 6 and 7 are vertically opposite. Okay, what can we say about 5 and 8? They're the same, yeah. So they're equal. Or 6 and 7 are also equal. Okay, so 5 and 8, example, 5 and 8, or 6 and 7, and these guys are equal. Okay, so what you might be asked to do is you might be given a set of parallel lines with an angle known, and then you may be asked to figure out other angles. And you may be asked to say, well, how do you know that? And this is where some of this vocabulary comes into play. Okay, so I'm going to stop now. Got to pause my recording.